breathe real slowly. Let it out, let it in. They can be terrifying, to be slowly dying, also clarifying the end where we begin. Let it wash over me, ready to lose my feet.
Hello, welcome everyone. Hope you had a really nice day full of interesting talks and hope you were able to attend every talk that you wanted to. Now we have something called lightning talks, which is a bit of a different format than what you've seen for the whole day. Basically, for the day, we had a list going on where you could sign up on your own. In case you didn't have a chance to do a presentation here, you have a chance now to do a 5-minute talk on a topic of your choice. It could be work, a personal project, what have you. So that is the format that we will be following today. And our first speaker is going to be Richard Siege, and he's going to talk about documents to mark down with images.
Big applause. So, something to mention in between. So, while Richard is getting his laptop up, yeah, we wanted to introduce, sorry? Who's next? Rodrigo is next. But what we want to mention in between, so as you know, like on a meetup, especially with lightning talks, it takes time to get up your laptop. So we have this little quiz. You don't need to attend, but just to kill some time, because awkward data jokes are generally too short. We have some if we need them, but we thought about this quiz this time. So if you can go to, and you want to participate, do it on your own in a group, you can go to cquiz.de, and we'll give you a pin in a second. And Akila will tell you now, actually, what the pin is.
So you need to go to cquiz.de, that's written over there, and the pin is 494106. It's 494106. Something to keep in mind, if you refresh the page, you're out and you can't enter again. And if you are out for whatever reason, you can't enter again. Yeah? We will also tell you the question, and then we'll ask you to be prepared to vote, so you have time to open the browser again. So, yeah. Let's just do one question, and then we can have Richard's talk. All right. In this movie, a glowing briefcase, a royale with cheese, a twist dance, and a boxer's fight are all part of the story. It also, thank you. It also includes hitmen, a pawn shop, and an overdose. What is this film? You have 10 more seconds to answer. All right, the answer was Pulp Fiction. And we're going to have Richard give us his talk now.
Thank you. So I'm going to talk about converting documents to Markdown using large language models and including the images in the documents. And it's a bit of a plea for help, because this is issue number 415 of there should be a solution out there, but apparently there isn't. So I was all alone on Stack Overflow and Reddit with this. So the task at hand is to convert a document into Markdown so it can use for further processing, for example, with large language models. And a little recap for the keynote this morning by Merv. Actually, I was quite happy to see this. She had a slide that OCR is more or less dead. So what you don't do anymore is OCR parser and then call your LLM. What you do instead is call your visual language model directly on the document. And multimodal LLMs are pretty good at converting PDFs to, or any document into Markdown. So very simple system prompt. Here's a document, converted to Markdown page by page, but don't say anything else. Then you input the your document as base64 images, and you get a really nice markdown. Like in this case, I took a PDF from the PyData Netherlands, and here you see a really nicely structured markdown. So what about images? Actually, Simon Willison 3 weeks ago had a blog post about this, calling LLMs and converting PDFs to HTML. And he had this nice quote, I've spent less than a total of 10 minutes using Gemini to convert PDFs. If I were to spend more time on this, I would target figures. I have a hunch that getting Gemini to return bounding boxes to figures on the PDF page could be the key here. And this is more or less my Fermat's last theorem. He says it's easy, but it's somehow not, or I am too dumb. I played around with Gemini and told Gemini to convert the document into Markdown and also give me the bounding boxes of all images at the same time. And here would be the results. This is the Markdown, and in the bottom, you see the bounding boxes, and you also see that the images were referenced at the wrong location in the Markdown. So the Amsterdam location should be, PyData Amsterdam location should be a bit higher, and also the bounding boxes are way off. So this does not work yet. If you know how to make it work, please approach me. But I made it work with GPT-4. What I'm doing is, first I extract all images in the PDF document using PyMu PDF. You need to import it with fits. Whoever, if you know why that is the case, please also approach me. Then you get all the images from the PDF, and then I add them to the input to GPT-4 and tell GPT-4, yeah, you also get a list of images along with their file names, and please reference these images in the Markdown at the correct location. And this only works if the raw image data is encapsulated in the document itself. So it wouldn't work if you have screenshots of documents. Some of our customers do this. So in this case, that's not possible. And the output is quite neat. So this would be the HTML conversion of the Markdown. So we see the images are in the correct position. What I also tried is the new package by PyMu PDF. It's called PyMu PDF for LLM. This is also a rule-based approach with all its shortcomings regarding regular OCR, and it really is a mess. I did not try yet a model that came out last week, which is claimed to have OCR 2.0 or general OCR theory model. Haven't tried that one yet, or one of the QWAN models. So if you have any ideas or thoughts, or if you're Simon himself, please reach out to me on my website. Thank you.
All right, thank you so much. That was a great talk, Richard. Okay, so the next speaker is Rodrigo Guirao Serrao, who is going to talk about, well, his topic says, Who Wants to Be a Millionaire? PyData Edition. And meanwhile, let's get back to the quiz. So, for the next question.
So the next question is actually, so you will not see it on your screen. I will call it out now. So this modern rock band, often compared to Led Zeppelin for their retro sound, gained attention with their 2017 debut EP. Their name comes from the local resident in their Michigan hometown. What is the name of this band? Yeah, the question should be any minute on your screen, but we're not fully sure. Technical difficulties, I hear here. Yeah, love this, Louis. Love this. Love this. Make it awkward. Love it. Okay. Okay, so live demos, you know how it goes. So we switch to the next speaker. The only thing that I would like to say is we set some timer. And as there is some, 5 minutes is really short. And it's a challenge. We start clapping with the 10 seconds left. So if you see Aquila and me clapping, start clapping as well. And then you know when the end is. Good luck.
Thank you very much. Hello, everyone. My name is Rodrigo, and I'm very used to the 5-minute rule, so I'll speak really, really fast. My question for you today is, who wants to be a millionaire? Let's play the game. I hope you all know it. This is going to be the PyData edition. But now, please don't sue me. There's no actual money involved. I just have a couple of questions. And I thought this was a really good idea, but now we have a quiz here. We have the Who Wants to be a Millionaire. We have the pub quiz later. So now I'm regretting my life choices, but I'm already here and talking. I will need 4 volunteers, so start to muster your courage. The playing levels, what are the levels we're going to be playing for? We're starting at the intern level. We will reach for the junior level, mid-level, a senior position, and then the final question will be for the data sorcerer supreme position. Now let's get started. I need a quick volunteer. Someone please get up and play with me. I promise it's going to be easy. If no one gets up, I will call out someone. One, I'm really short on time. No one is able to help me? Rich, can you? Okay, come on, go ahead. All right, excellent. No. You need to stay there, sorry, because I have very short time, so you cannot come all the way here. So, for you, my friends, loosely speaking, what is a data frame? And now before I give you the options, I googled cheese images on a transparent background. I found this. And the file name was cheese on transparent background png.png, but still the background isn't transparent. The internet is a lovely place. So option A, is it this one, option C is this thing, or option D? Now wait, I can give you some help. Do you want to use your B64 power-up? The answer is yes. So let's base64 decode the options. So loosely speaking, what is a data frame? B? You're playing me. Don't do that. I'm the one supposed to be making the jokes. All right, so let's go with D. Well, I thought this was correct. And we should all cheer because our friend over here got it correct. Please. Thank you. But also, I just came from a talk where we argue that data frames are one-dimensional, so James Powell is now looking at me like this. But it's fine. It should be fine. All right, question number 2. Who wants to play? Can someone please get up? Excellent, over there. I hope you can scream. So your question for you, my friends, which of these is not the name of a classic data set? Is it A, Iris, B, Titanic, C, Pupil, or D, Amnist? Now, before you answer, I can give you some help. Do you want to use our power-up? The correct answer is yes. Yes. All right. So what I did is I asked this same question to 3 different LLMs, and these are the 3 answers, so they all agree on C. So do you want to log answer C, or do you want to go for something else? All right, let's log in answer C, and it's correct. It's correct. Applause. Last time I played this, the LLMs actually got it wrong, so the person playing got it wrong as well. It was lovely. Question 3, from mid to senior. Who wants to get up? Who's playing with me? Okay, don't raise your hand, just get up. Excellent. Hey there. For you, my friend, the question is, which of these is not a matplotlib style sheet? A, ggplot, B, fast, C, 538, and D, colorblind. Now, before you answer, you have a power-up. You can ask anyone in this room for help. Do you want to use your power-up? Totally yes or totally no? Totally yes. All right, who are you going to ask for help? I'll give you... Someone seems to know the answer. All right, so what's your answer? B, fast. I'll give you some other help. I keep turning my head around, but the microphone stays put. I'm also in this room. You can ask me. I do not agree with... Let's try D. Try D. Yeah, go for D. So what's your answer? B? No, no, no. I don't think you understand the assignment. I'm telling you it's D. What's your answer? I think it's D. D. All right. I don't know what's going on. I can't hear. That's why I keep doing this to my eyes. But I think you said D, and it is correct. It's colorblind. Final 5 seconds. I'm almost out of time. Consider the following XKCD comic. All right, if you're laughing, you already read it. What's the idea of this comic? And for the answer, you'll have to meet me later because I'm way out of time now. Thank you so much for your attention. Bye.
Thanks a lot. That was a great talk, also very entertaining. Next up, we have Leon Overwell on the topic when files lie about their time zones.
Hello. Hello?
Woo!
Okay, yeah, I promise I'm not going to be as funny as the previous guy, so set your expectations accordingly. So yeah, I want to talk about time zones because programmers love time zones. But first, I want to start maybe with a bit of a broader question, which is, do we live in a perfect world? Feel free to just shout out. No, because if we did, all time series data would be stored in UTC. Now, given that we don't live in this perfect world, can someone tell me the worst thing about this daytime? No time zone. We don't even know if it's in UTC or not. Terrible. Now we know it could be in CEST, Central European Summertime, which is what we have in Amsterdam right now for at least a couple more weeks. Now, this is a problem that, I work on forecasting renewable power, and then you get a lot of data sets that are time series-like, and customers don't really like submitting that in a nice way. So sometimes you get a data file like this that has some historical production data. This is from some Italian wind parks. Now, you can already notice that the first thing about this is that we actually have 2 daytime indexes. That's great. Great start. Now, if we want to try to figure out what the time zone of this is, there are a couple of hints we can use. So maybe you can see that, OK, here the first row is starting at 2300. The second row, or the first row in the other column, is starting at midnight. Now, I've been through this rodeo a couple of times, and to me, this means that most likely the left one is in UTC and the right one is in CET. How do I know that? A lot of crying. Anyway, you don't always get lucky like this that your data set starts at an hour, which gives you a hint about the data set time zone. Sometimes it just starts at midnight. So what do you do now? Well, you do some other tricks. You see, are there duplicates in my index? Oh, look at that. There are duplicates in my index. What could it mean? Oh, my duplicates are at the end of October in 2023. What happened at the end of October in 2023? Look at that. In Amsterdam, we changed to daylight savings time, so we had an hour double. And then if I localize my data set to the Amsterdam time zone, all of a sudden my duplicates disappear, and yay, I have now found the correct time zone for my data set. This is when you clap. Thank you. Now, of course, I'm a programmer, and sometimes I go on holiday with my parents, and I'm stuck in a cabin in the woods for a while. So I start thinking, can I automate this? And apparently I can, because otherwise it wouldn't be up here. So yeah, I built this thing called Time Zone Canary. It's a canary because, time zones make people die. So what it does is, you import this same data frame. You import validate time zone, right? So we're going to ask the canary, hey, this file that I just gave you, the same one where we just figured out is Amsterdam, could this be a time series from New York? Canary died. It couldn't be. It says implausible time zone error. The given time zone is not plausible for the data you've given me. Here's a list of what it could be. Now, if we ask it, could this be Amsterdam? It says, yes, it could be Amsterdam. And then what you can also do is just ask it, hey, what time zone could this possibly be based on when I'm seeing the DST changes? Now, the nice thing is that all this DSC data is actually already on your computer. All I have to do is just read it out. So yeah, not a lot of random data being shipped around. Anyway, I think I am nearing my 5 minutes. So yeah, check it out. You can fork it. You can pick up an issue. Yeah, I work at Dexter. So if that sounds cool, come talk to me. Bye.
Thanks, Leon. Next, we have up Bruno Lando. Applause. Yes, thanks.
Hello, yes, I'm Bruno Lano, and I care a lot about software craft and writing readable code, but I also sometimes struggle with readable data. Yes, and I want to talk about that because I see like a lot of machine learning and data science projects are just starting to test often, and they, I think, bump into this idea of like creating CSVs to have data to test on. And I think there are different ways you can do that, and some are interesting to be aware of. So first, I want to ask the audience, I hope it is readable on the left, the code. So you have on top like one scenario test value that generates some test data, so very abstract level. And on the bottom, you have like 3 different methods that together work to generate tests. And like, I'm wondering, like, without trying to guess where I'm getting with this, which one is simpler according to the audience? So who thinks one is simpler? Yeah, we have some hands, OK. And who thinks 2 is simpler? There are definitely more people who think 1 is simpler. And I think it makes sense. We have a lot less code. And the second one, like, there are different things going on. So I would think like that is fair. But which one is more readable? So who thinks 1 is more readable? Similar amount of people. Who thinks 2 is more readable? Still fewer people. I would argument that this is a different question. So I think the number of lines of code is not the same thing as being more readable. Readability is about communicating intent and like answering the why. Why is this data looking the way it does? In the first scenario, we have just a dump of data, and this might be a data dump from some anonymized data from production, but we don't know exactly why is there this kind of variability in the data. Why these 0.1s and these 0.2s in the data? Like, that's not clear. In scenario 2, there is a story. Like, if you start like from the bottom, like you have the base values. So there's something about the columns, like or values. There is like some kind of reference, and those are the most basic thing you could imagine. So this is clearly synthetic data, and this is not just for the example. This is just to, in a test, you would also use like random numbers. So value 1, value 2, value 3, what you would expect to be the most basic synthetic data. And then how is the reference case? And with the reference case, I mean like it's a happy path data in our story. We'll have one test that does the happy path. And there, like, it's just a bunch of rows of this reference data, except column 2. In this happy path, we're working around column 2, so we change these values for each row. So this is the same column 2 as in the other one. It gets overwritten at that level, but it's because we're at a different level of our storytelling of what is the intent of this data. And then we move to a specific scenario. So this would be on top of the happy path. We have some kind of exceptional corner case we want to test. So now we're going to be overwriting yet another value. So column 3, there we will overwrite something else. So I would argument that even though this is maybe less simple, it is more readable because it tells you a story. It tells you what is the intent of this code. And so if you go into like a more complicated case here, like we have like a very large CSV, and that would be like a data dump. And yeah, it could look simpler because there's a very nice structure. Like these columns are all aligned. There's clearly a lot of duplicate of data. Like it's in one eyesight, you understand this as a CSV. On the right, you also have like some kind of logic that is changing something. Like there's something about in the year 2022, the visibility was low to 0 and high to number of countries. So like there's something going on there. And now 2022 has the opposite, has high to 0 and number of countries to low. So there is something changing there. And of course, in all fairness, this is not the only thing that is in my code base. There is also a bunch of other code for this higher level. So there's a lot more code and some for loops for generating all the dates and a lot of base values for a lot of columns that I'm not using in this scenario. But even though you have to read more code to understand the full test, you can write many tests where only that last bit is like the thing changing. So there's not that much more code per single test. There's more code for the first test you read, not the next ones. And in the CSV, we can't really see like what is actually happening in this data. I explain it to you on the right, but if you now move on and I highlight it, you can see it in the data too. Like this visibility high and low is also switching there. And you can see that the number of countries is switching column there from visibly high to visibly low. But I assume that like no one was able to see that when they saw the CSV. And I think that is what I'm trying to highlight. I'm not saying that this is always like the solution. If you are taking a data dump from your production and you're anonymizing it and you want to know, would my code crash if I ran into the data? Then it is not a solution. But in other cases,
So sorry, I feel like a bouncer. Thank you, that was a wonderful talk. Next up, we have Johannes Werner, challenges in civic monitoring of clinical trials. Do we have Johannes? All right, let's hear it.
Yeah, hello. I'm coming without slides because I figured that at the time where I was entering my name, I will not do anything that is decent to this audience. So this amount of people is a bit unusual for me, so my apologies if my voice sounds a bit nervous. Quick show of hands, who is working in academic sciences? Okay, good. Then I'm glad because less people will be depressed. My second point was actually I wanted originally talk about code quality, especially in high-impact journals, but I rather wanted to talk about something fun, and this topic is not fun. It is sad, depressing, and extremely pathetic. So instead, and that is also maybe not such a high-burning topic, I decided to talk about my work instead. It's maybe not fun because I really don't want to say, what do you do for fun work? Because this is maybe sometimes true, but not the first thing that you should know about me. But at least it is not as pathetic as the first thing I was starting to talk about. So I'm working at a small company in Heidelberg. We are dealing with patient stats in supporting clinical studies, mostly phase 1 and phase 2. Just to give you an explanation, phase 1 clinical studies focus on safety. So how much of a drug can I give to my patients before I'm poisoning them? And phase 2 is basically to look into efficacy. So what is actually happening there? Since my background is in bioinformatics and not in biostats, I started at some point developing clinical dashboards instead. And I want to highlight that this is a topic that is, when I started, I thought this is a complete nightmare. I wanted to share a few points and maybe leave at an open question in the end. So to report in clinical studies, of course, all of this is sensitive data, meaning this needs to be communicated in a more or less secure way, or at least I hope it is communicated in a secure way, by so-called ECRF systems, electronic case report forms, which basically allow clinicians and everybody who is involved in the study to enter that into an ugly web framework, which I believe was already not modern in the 2000 years. I just really hope that their security is not on that stage, but I was not willing to do some penetration testing on that. First, because I know that this is not allowed without permission, although I'm not quite sure how much that would prevent me, but mostly because I'm a bit sad about if I wonder how the outcome might look like. With that in mind, I saw how people are looking for serious clinical events, which basically means every few days they log in and see if some of these subjects, which is a horrible a nightmare to query how they are accessing that. And I realized, okay, there must be a better way. So basically, I built a web platform on AWS, queried the data from the FTP once per day via a cron job, and built a dashboard with Streamlit over that. Combination with Python and R because the SaaS company decided to make their point in clinical studies and define the standards, which is always quite amusing to work on very unclean data and produce standardized outputs in the end. So that is not such an easy thing. But after finding Calm code and using Cookie Cutter to a high extent, I realized that my life got much simpler. And the deployment time from 2 months to 3 weeks ended up now in about 2 days. So what kind of problems do we facing here? The problem one is that the data is always in a severely bad state, and because there are not a lot of constraints on the data, we often find things like adverse event happens about 1800, which is probably not true. The other thing is basically these kind of things can, of course, be tackled with something like greater expectations and automatic notifications, but this is, of course, something which also needs to go over a secure channel because I do not want to work on a safe system and then send all of that via unencrypted emails. The last point, and this is basically, if anybody has an opinion on that, I'm really happy to hear about that, is changing basically minds of clinicians on how to do that. Because if you deal with people who are working a lot of time in their standardized system and their way of dealing with this kind of data, it is usually not the kind of tool that decides on how this is actually dealt with, but rather how can you empower people to understand that there is a different way of dealing with that, and how are possibilities to show people that there might be a better alternative. Thank you very much. My first lightning talk ever, especially for such an audience. First PyData. Yeah, first PyData lightning talk. Thank you.
Well done, well done. Next up is Sartak Anand with the NLP Survival Kit. And yeah, just a question. So do you want like a stupid data joke? Yes? Oh, I know. I will ask for the answer then. So, how do you call cheese that is not your cheese? I will ask Louis.
I have no idea.
Anyone else? What?
Nacho cheese.
100 points. But now over to Sartak.
So I just played this and it goes up. Oh, okay, so this time. Hello everyone. My name is Sartak, and I wanted to give some information about like help with NLP. So I want to start with my background a bit. So I've been working on NLP for quite some time now. I started as a research intern working in an academic lab. Then I worked for some time in a startup like H2O.ai. Then I went at IKEA, and I worked on training some language models at IKEA. And currently I work at Decathlon to work again on some language models. So I've been working quite a lot in NLP as well. So, and I wanted to say that life was very easy back in like 2018 or 2019. All I had to worry about LSTMs and Word2Vec and RNNs. And NVIDIA was still a gaming company. Like we didn't have a lot of GPUs. We just used to train language models just on my CPU instances. But things started to change a bit after 2019 or something, like the BERT came. I actually went to the conference where BERT came, and everyone just started about these transformers. Like, and you had so many variations of it. Like you had ULM-FIT, BERT, XLNet, Elmo. It's like it started to explode a bit. And the problem started to happen really now that you have so much terms right now in NLP, that you have pre-training, you have post-training, you have DPU, and you have so many versions of LoRa. And like, you really don't know, like you have LoRa, QLoRa, and you really don't know if someone is just saying something or it's actually an algorithm that we use. And it just reminded me of this meme. It's just like, you have so much terms and you just don't know if it's real or not. And I wanted to do something about it. And it's not only a problem for me, it's actually a big problem for someone who's just starting in NLP as well, because like, for me, it's a bit easier because I'm learning the problems one by one. But like for someone who's just starting to do an NLP, there are so many terms, and it just gets overwhelming a lot. It becomes like finance field, like you have so much terms, and it's just super hard to get into those fields. So to do this, I started to build some flash memory cards for myself, so that I could really understand the topic, but like in minimal amount of way, and like just visualizing the concepts, like all those different concepts. And if you do this, it makes really easy to understand really hard algorithms. Like if you don't know anything about PPO versus GPO, all you need to know in DPO, you just have an accepted answer and a rejected answer. Versus in a PPO algorithm, you have ranking of the answers, and all you need to train those models. And it made a lot easier for someone new to understand these concepts. So I made a lot of these flashcards for myself, and I wanted to just share it. So if anyone also wants to download it, they can just have it for free.
Thank you. That was absolutely on time. Appreciate that. The next talk we have from, sorry if I mispronounced the name, Shuk. Yeah, and the topic is missing data can be fatal, literally.
Okay.
Meanwhile, just a brief one, because someone messaged me with a joke. I had to laugh for just a second. So it's green and it skis down the slopes. What is it? Volunteers? Hands? What? Who? What?
A kiwi.
It's kiwi? No. It's a hachi. Okay, let's go to the talk.
Just to understand the jokes, actually. Yeah, so, well, I hope this will be quick. I only 5 minutes, but I'm going to tell you why missing data can be fatal. And it's not like funny at all. So I have been told recently that actually a lot of data that we have based on male, including like maybe average size or average height or average weight, shape or behavior, they are all depending on data that are collected from men. I'm not surprised because women only, who knows that like since when women in UK can have a bank account? Any guess? 72, close, not quite. Any more guesses? 80? No. It's 1975. So it's still quite recent in history. People who are like, nowadays there's still people alive, remember 1975? So it's only that reasons that women can have a bank account, which is a bit crazy. Nowadays, we're past that era now. We are now like, in a more modern world. Bias of data is, we talk about it all the time, right? We talk about, maybe sometimes you play around with some LLM or gang model, and then they give you something funny, and then you think, maybe like because the data is biased, or, there's stereotype. I feel like I'm a broken record if I keep talking about let's say I asked for a, flight attendant, usually like they would give you a female picture, or like I asked for a doctor, usually they give you a male picture. Those kind of things, like we talk about it all the time. But it's not just that. For example, there are actually data that, are missing for women. For example, let's say we need some protective clothing for, let's say, police officer, like, for example, the vest that is like bulletproof vest and all those things, they are designed for an average male body. It actually doesn't fit a female body, and without considering women's need and their physiology, it could be, giving women some uncomfortable or like sometimes, inconvenience. But sometimes it could be deadly because those protective gear, if it doesn't fit, it doesn't protect you well. So a lot of times, like for example, you may have go to a shop and buy a T-shirt, and you look for the size and stuff. If it's a unisex size, actually a lot of times it means straight cut, which is suited for male body. And so if it's a T-shirt, it's fine. Maybe it's a bit unfit, doesn't look good on you. But like I said, if it's the protective gear that you wear, like you could die if it doesn't protect you properly. So, but not just that, medical things, a lot of women, they got misdiagnosed, or it takes a long time for them to go to the doctor again and again to get the right diagnosis. And, I think it's not a joke, but it's a thing that like people keep talking about. Like, if you have if a woman have stomach pain and like go to see a doctor, sometimes the doctor will be, oh, it's just like PMS, like it's very common, and it could be something serious that the doctor will overlook. So I would say that it's not just the bias of data, it's the missing of data, because women's data has been missing, can make 50% of the population suffer. And so we have to consider this, take into consideration not just women, but also underrepresented folks. Like, we don't just look at your typical people's data. So if you want to know more, this is a really good book. I learned all this from this book. They are on Audible, PDF, whatever. Like, you can also buy a book from your bookstore. So thank you.
Thank you. Wonderful, wonderful talk. So next up, we have Mohammed Dakiu on the Fellowship of Kaggle. Let's go. All right.
Hi, everyone. I'm going to talk about how I created a fantasy world on Kaggle and won a competition on Kaggle using data. So the real story happens 2 years ago when I participated in a Kaggle competition based on the machine learning and data science survey. So every year, Kaggle conducts a survey. They ask people, and then they immediately they ask people, basically they create a competition and ask people to analyze it, and the winner gets a prize. So, I was interested in fantasy since I was a kid. I was reading a lot of fantasy books. When I was a bit younger, I was playing some RPG game. When I was a bit also younger, so I said like, we have different roles in the data science world, and they could be each a hero. So with different skill sets, strengths, and weaknesses. And here starts the story. So the story happens in a place called the data world. In the data world, everyone lived happily and in harmony. Everyone had enough amount of data, not too much, not too little. They crunched their data in spreadsheets, they created pie charts, but it did not last long. So then we had an era of digitalization. And then a creature, a malicious creature, emerged called the data monster. And it had a very destructive weapon called big data. It flooded the data land with a lot of data, created data lakes, broke pipelines, and brought chaos. So then there was a secret council, and they decided to create they assembled a group of heroes in the data science world and fight the data science monster. So I'm going to introduce you to the heroes. So we have the data analyst, who is basically the ranger of the data world. So they are lightly equipped, but they're agile. We have teachers or professors. They live in the island of academia their entire life. We have research scientists. They also live in the island of academia, but they venture to the kingdom of industry to get more money. We have statisticians. They're poor, but they're good at R. Then we have a very mysterious creature called ML engineer. They are very good at almost all the skills. They are hard to distinguish from the data scientists. We have data engineers. They are the blacksmiths of the data world. They create tools for data scientists and other people. And then we have the managers, which basically keep the morale of this assembly of champions. So I'm still working on the story. So the battle is continues. So if you know someone in Netflix, let me know. Maybe we can make it into a TV series. And yeah, I think it should be. I think it should be successful. And yes, you can find the notebook, the Kaggle notebook, scanning this core. I did all the visualization in R and ggplot, even though it's a Python conference. And the images were created using a stable diffusion and the icons. Yeah. Thank you.
Thanks, man. This was a creative one. Makes me actually want to check Lord of the Rings again. Yeah, last but not least, we have James Powell with maybe no need for pandas.
This is Maybe No Need Pandas. I'm James Powell. We're at PyData Amsterdam 2024. It's Thursday, September 19th, 2024. You can follow me on LinkedIn. I don't really care one way or the other if you do or don't. But let's take a look. Stop using pandas if you don't care about the index. For example, if you have some kind of trading data, and the data looks like this. There's a column for the date, a column for the ticker, and a column for the price. And the operations that you do on this data are to perform operations like group by and then pull out the price column and then aggregate, and then you say, oh, but it gives me an index, so I want to reset index. You probably would be better off and happier using something else. Because fundamentally, what makes pandas a good tool to use is the presence of the index, modeling, for example, this data as a one-dimensional series with a hierarchical multi-index of tickers and prices, and everything just works. If you fight against the index, it will fight back. It will win, you will lose. Now, when I say maybe no need pandas, I don't mean that we even have to use anything exciting, like polars or DuckDB, although those are fine tools to use. In fact, we can get quite a bit done with just NumPy. Let's assume that we have a pandas data frame with 3 columns, X, Y, and Z. And these are heterogeneous columns, that is to say one is floating point data, one's integer data, and one is some sort of string data. And we want to model this without using pandas. But we still want to be able to represent this as some sort of contiguous, homogeneous, machine-typed data. Well, we can use a NumPy ND array. And many of you have been using NumPy for a long time. Remember when this thing used to be called a rec array, and it was a special import? They actually put a little bit of work into making this thing work a little bit better. You can have what are called structured D-types, where your D-type has multiple components to it, and you can get really close to what a pandas data frame may look like. Here, we have an empty structure of 100 elements, where the D-type is a floating point value, an integer, and a 1-character Unicode value. And we can model this data contiguously in memory, where every other value happens to be our integer value, every other value happens to be our floating point value, every other value happens to be our textual value. And we can actually use this to perform operations. We can access the individual columns using the square bracket syntax. So I guess we don't have that dotted syntax that people like to use when they really hate typing, when they're using pandas and they want to grab their columns. But we can access one of the columns. We can get the first 3 elements from that column. This is our equivalent of a .head operation. We can perform aggregated operations inside the restricted computation domain, just like we can in NumPy, except we can have very fine-grained control over the amount of memory we're using, whether something's a copy or a view, and all of the things about NumPy that makes it very easy to reason about, that makes pandas, with its fantastic block manager, very difficult to reason about. Here's a little bit of code showing how this may play out in practice. It's a little bit of code that I wrote for somebody to illustrate what you can actually do with these approaches. They are limited. Pandas, for example, makes it really easy to work with time series data, to do operations like rolling or diffs or whatnot, and you can still do it kind of in NumPy, but some of these things are difficult. Do note that there are certain operations that you can do in NumPy way faster. You can do them in pandas. For example, using numpy.lib.stridetricks, that sliding window view, can actually in many cases be faster than a dot rolling with a fixed window size. But here I have some machines, and I want to get some information about these machines that are represented in some n-dimensional structure. We can actually take this kind of record data and store it n-dimensionally using a record D-type. Here I have some idea of machines that have a name, a rating, whether they're in use or not. I have primary and backup machines, so I have this n-dimensional nested tuple-like data with different fields. I can populate it with maybe not 1 line of code, but with 3 lines of code. I can access individual elements, so you can see one of these entries, or I can look at these in different reshaped orientations, for example, with the pairs of primary and secondary, or just flattened as all of the values. I can even do complex selections into this data in just basic NumPy. For example, if I had some metric by which I want to go replace certain machines that belong to a certain site under certain conditions, I can just write simple NumPy code to construct masks and to mask out this data in the way that I want, and everything just works, and I have a very reasonable way to think about how these operations work. I can assess what's a copy or view, what the performance will be. There's no notion of, oh, this is a fast path and it's faster, but if I make a small change, it becomes slower. Everything is more or less uniform speed. Maybe no need pandas. NumPy enough. Thank you very much.
Thank you so much, James. That was an amazing talk. This is the end of the lightning talks for today. So thank you, everybody, for attending, and thank you to the speakers. Before we disperse, I would like to thank our sponsor, Snowflake, for sponsoring the social event that we're going to have after this. And stick around for the pub quiz that's going to be hosted by none other than James, who just gave a talk. And hope to see you all tomorrow again, same time, at 9 a.m. We start with another keynote. Thank you so much.